Right. So the next topic that we are going to see is Newton's laws of gravitation. So what does it say? The force between any two massive objects is proportional to mass of the individual objects and inversely proportional to the square of the distance between them. So here the objects are considered to be point objects. Okay. So let's say whatever you are considering, the two objects are assumed to be point objects, and let's say the separation between them is r. Okay. So this object is pulling the other one in this direction, and m2 is pulling m1 towards itself. So what is the direction of the force? So let's say F12 is m1 m2 by, so the proportionality constant is g. Positive. Minus on that. I don't think so. So here, what is the direction of this force? So what are all the vector quantities in this scenario? Force is a vector, mass is not a vector, so radial distance is a vector, but what is its direction? So ultimately you have to fix a direction for force. So you have to write it as g m1 m2 by r cube, let's say r12. You should give some direction to it. Okay, I mean you have to separate a unit vector along direction of force and write the rest of the terms. So the force is directed from 1 to 2. Maybe there should be, okay, we'll see the direction part. So as per this equation, it is directed from 1 to 2 in this way, but it should be attractive. So that part we will see. But I mean, primarily there is an attractive force between these two, and these two objects will try to move towards each other. రెండు కూడా ఒకే డైరెక్షన్లో దే మూవ్ టువర్డ్స్ ఈచ్ అదర్ అండ్ మీట్ ఎట్ ద సెంటర్ ఆఫ్ మాస్. Right, so this direction of force is a matter of discussion that will continue in the next session. But for now, the most important issue is so each body is attracting the other one, and both of them meet at their center of mass. Okay, so we have to identify that the location of center of mass. So here the total radius, let's say this is r1 and r2. Yeah. Center of mass of the binary system. Binary system. Okay. So if you consider both of them as a single object, you have to identify the center. So the total radius is r1 plus r2, and the moment about center of mass, that means the product of mass and distance is the same. About the center of mass. So I call that as a location of that center of mass. The center of mass is located at a distance of r1 plus m1 and at a distance of r2 from n2. So now we have to identify that. So this can be written as so m1 r1 is equal to m2 r2. So from here I can write m1 r1 is equal to, I am trying to eliminate r2 so that I will get a value for r1. Okay. So my aim is to get the value of r1 from these two equations. m1 m2 are known. So I am eliminating r2. So m2 times r minus r1. So what do you get? m1 r1 plus m2 r1 is equal to m2 r. So from here m1 plus m2 r1 is equal to m2 r, or r1 is equal to m2 r by r1 plus r. M1 plus m2. Same way, if you eliminate r1, we get r2 as m1 r by m1 plus m2. Okay. So what do you get? What do you infer from here? What is the location of r1? Let's say m1 is massive. M1 is very large, like our solar system, Sun and Earth, or Sun and Neptune, Pluto, very small planets. And Pluto is not a planet now. So M1 is very large. So what happens to R1? So somehow you have to place m1 is equal to infinity in this equation, or in this equation. m1 అనేది infinity వచ్చేలాంటి ఒక arrangement చేయాలి. So here there is no issue. When you substitute, so m1 tends to infinity, r1 is m2r by m1 plus m2, which is 0. Okay, what about R2? You have to place an infinity here and infinity here. So whenever you have infinities in the numerator, shift it to denominator. Okay, so this equation becomes R by m1 by m1 plus m2 by m1. So R by 1 plus m2 by m1. So R2 is equal to R by 1 plus the center of mass lies now at m1. R1 is 0. So it is at a 0 distance from particle m1 and at a distance of r from m2. So in that case, the planets will move. So The same rule applies even for apple and earth. So if apple falls from a tree and moving towards earth, what is the force? So earth is attracting apple with certain force, certain amount of force. At the same time, earth is attracting apple, right? At the same time, apple also attracts earth with a equal amount of force. The force is given by this gm1 m2 by r square. So what happens? As long as apple moves towards earth also moves towards apple. Apple earthward postu untundi, earth also moves towards apple. So what is the amount of displacement? I mean, both of them meet at the center of mass. So here m1 is very large, so r1 is nearly 0. I mean equal to 0 actually. R2 is equal to R. So apple travels a distance of R and earth travels a distance of 0. But the force is equal and opposite. Okay. And people call this one as a gravitational force offered by the first body. So that force is equal to mass of the second object times gravitational force offered by the first body. So what are all the factors that this one depends upon? The gravitational pull offered by Earth or Moon or any planet, any massive object. It depends on mass of the object, mass of Earth, let's say. What about this? Radial distance between the object to be pulled and Earth. Then, is it a variable? Let's say gravitational pull of Earth is some 9.8 meters per second square. G is a constant, m1 is a constant, r it depends on the other object, right? How far is it located? Then how can we define it as G? So this we'll see in the next session. So this is the reason why these planetary orbits are elliptical in shape, because the planets revolve around their center of mass. So let's say there are two planets and their center of mass is this. So this one will revolve around this point, and this one will revolve around this point. Sorry. Let's say this is the center of mass. So then the heavier planet will revolve around that center. Other one also will revolve around this point. So when you take a comparative locations of relative locations of these two, let's say the heavier planet may be here and other one lighter planet may be here. Sometimes the heavier planet may be here and lighter planet may be here. So if you check the relative locations of those two planets, the orbit will be elliptical in shape. The rule is both the planets will revolve in circular orbits about their center of mass. So about the center of mass, the shape of the orbit is circular. So let's say for Earth, Sun and Mars system, the center of mass lies within the Sun. So the orbit of Mars may be mostly circular, whereas for Jupiter, the mass is heavier and comparable, and the center of mass is outside the Sun and Jupiter system. So the shape of orbit for Jupiter planet is strictly elliptical. So they are called binary systems. Well, the rule applies even for stars, like Vasishtha and Arundhati. They are binary stars. So they revolve about their center of mass. Okay. So this G, from this equation we see it depends on R. It looks as if it is a variable, but we are considering G as constant for a given planet. So we'll discuss that in the next session.